After reading the definitions for the divergence test, let's do a couple examples. So the first one I have is a series, summation n equal to 1 to infinity, n over 3n minus 1. So we notice that this is the summation portions of the symbol, and here is the an part. Remember that we're going to generally writing a series as summations n equal to 1 to infinity of a sub n. So the a sub n here is corresponding to here. So we said that for the divergence test, if we take the limit as n goes to infinity, a sub n, which talking about the nth terms, the more like the last terms of this infinite series, if this limit is not equal to c, or is a number that is not equal to 0, or does not exist, then we can conclude this one is divergent. But if it equals to 0, we cannot conclude it's convergent. It's going to be inconclusive. So for this case, we're going to checking these portions. We're going to check what is the limit as n goes to infinity of n over 3n minus 1. So we cannot really just plug in the infinities here, because if we do, we will end up with infinity over infinity situations. So there are a couple ways you can do. Normally, what I will do is I like to do algebra versions, which means I will divide every single term by the n. When I divide every single term by n over n, which is going to be 1, 3n over n minus 1 over n. Okay, so to save some space, n over n is going to be 1. 3n over n is going to be 3. And I know that the limit of 1 over n is going to be 0. So this whole thing will become to 1 over 3 minus 0, which is going to be 1 over 3, which is not equal to 0. So by the divergence test, the series is diverge. Now let's looking at another example. I have a summation n equal to 1 to infinity of 1 over n cubed. So 1 over n cubed. For this one, is pretty straightforward. The 1 over n cubed portions is pretty simple. So we can just pretend we're going to plug in the infinity in. So if we're going to plug in the infinity, we will end up with 1 over infinity cube, which is going to be a 0. And when it's 0, we cannot say anything. So the divergence test is inconclusive. One note I want to point it out is you probably see that here I'm using the equal sign, here I'm using the arrows, because this portion is not going to equal to 1 over infinity cube, because we cannot calculating infinity. And also here we're actually doing some algebra. So that is why I'm using equal sign here to be more sure that this is equivalent to each other. Here is more like this one is going to approaching to this form, which is going to be approaching to 0. So that is more like the limit situations. Now the third problem we have is a summation that n equal to 1 to infinity of e to the 1 over n squared. So e to the 1 over n squared, if we plug in n as infinity here, we will end up with e to the 1 over infinity squared. And we know that 1 over n squared, or the limit as n goes to infinity of, I think the notation-wise I was a little bit off. Let me fix the notation really quick. So I'm talking about the limit as n goes to infinity of 1 over n cubed. Okay, so the limit of 1 over n squared, this one is going to be equivalent to a 0. So this limit of n equal to infinity of e to the 1 over n squared is going to become to e to the 0's power, which is going to be 1. And we know it's not equal to 0. So by the divergence test, the series is diverge.